This concept video we're going to be discussing polar coordinates. You've probably been very used to, and in your math classes up until this point, you've been using one type of coordinate system. And that one type of coordinate system is called the rectangular coordinates. So the rectangular coordinates, we can take the location of a point, and by the way, we're going to draw the exact same location between these two charts, so go ahead and put a dot in exactly the same spot. But in rectangular coordinates, we would to get to the point, we would say how far right or left you need to go, and that would be the x direction. So we'll just remind you here about the x-axis, and this distance here would be, x, and then the y part would be the up and the down part. So we've got the y-axis here, and this distance right here is going to be the y. And then we would name that point with an ordered pair, and it would be x comma y. Well, there are actually a variety of ways that we could find that location, and one way that we can do that, or we can describe the location of the point, is with a polar coordinate. Now you'll note that for rectangular coordinates, this x comma y, that describes a unique location, and there's only one way to describe that location. For instance, if the x changed at all, you wouldn't be in the same spot, or if the y changed at all, you'd be somewhere else. So there's only one way to do it. Polar coordinates, instead of doing x, y, left, right, up and down, what we can do is we can describe the location of this point with a distance from the origin known as r, and then also, and we'll try to make this a different color here for you, with the angle from the positive x-axis. Well, actually this is not the positive x-axis anymore, because this isn't rectangular coordinates, or the rectangular coordinate system. So what we do is we call this the polar axis, but it's in the same location as the positive x-axis. So you'll recall that basically all you're doing here is drawing an angle in standard position, with the polar axis being one part, the initial side of that angle. So when we write this ordered pair here, what we do is we write this in terms of r and theta. So the r is going to come first, and then the theta is going to come next. And this actually can describe the location, the exact location of this point in red right here. So new coordinate system, we've got our old coordinate system, our rectangular coordinates, and the new coordinate system is instead of left, right, up, down, it's how far away from the center, or this is also called the pole, and then the angle between the polar axis and that point. We're going to move on now to the next part of your notes here, so we're going to transition right to this one, how to name a point in polar. I hope you can see this. I know it's probably going to be pretty tough for you to see maybe there at home. I'll try to move this up just a little bit. But basically what I've drawn here, and you might have to zoom in a touch, but I've drawn 3 points. So we'll make A red. So there's A, and then this will be the red dot, okay? And then we've got, maybe we'll do a blue dot, so that'll be B, so B will be right here. And then additionally we'll do maybe one in green or something like that, so we'll go, this green dot will be C. And what I've done, you can pause in the video if you need to, is I've taken the chart that you see in your notes, and this I've arranged so that each one of the darker, like the bold rings, is going to be 1, so each one of the small rings here would be a half, like 1.5 would be here, 2, 3, 4, and 5 would be the outer ring. So you want to label that, and then I've also done all the angles all the way around, and I've had to draw in these 45-degree measures. So please do that if you need to, and then put your angle measures all the way around. Use both degrees and radians. We're going to be transitioning between each one of those. Alright, so let's talk about describing point A. One of the most basic ways of describing point A is to just take a look at the polar axis, which is here, and then figure out what line this thing is on. So the angle measure is 60 degrees, and then how far away it is from the center. So from the center it's 3, a distance of 3 away, of the radius, we would say, of this circle here that contains that point is 3. So remember, we're always going to go r comma theta, so it's going to be 3 comma 60 degrees, and that'll describe that location. Now this is unlike rectangular coordinates. Rectangular coordinates, you got one x, you got one y, that gives you a point. If you change either one of those, you're not at the same point. With polar, there's actually an infinite number of ways to describe this point. And what I'm going to do is I'm going to change this radius on you, and I'm going to make it negative. So if we want to still come to this point, and our radius is negative, of course on a number line, if you remember, like from middle school and grade school, if you had a number line, just, you know, x or something like that, and instead of going right by, let's say, 3, if you were to put a negative 3 there, that would mean left, or in exactly the opposite direction. So if I put 60 degrees here again, actually we would not want to go in the direction of 60 degrees, we would want to go exactly opposite, so we'd be over here. So to find the location of A, if you're going to use a negative r, what you need to do is you need to look at this line, and you're going to go to the other side. So instead of 60, this is going to be 240. Another way of figuring this number out is to just add 180 or even subtract 180. That would work as well. Yeah, negative 120 would work. That'd be down here. So anyways, if you use a negative radius, it just means go in the opposite direction, and 240 would be all the way down here. Instead of going 3 units in the direction of 240, we just go 3 units in the opposite direction. So this actually still does describe point A. So there's a number of different ways that we can come up to this location in polar. One other thing I'll mention to you is using a positive radius, but using a negative angle. So instead of rotating in the counterclockwise direction, we could rotate in the clockwise direction. So this would be 90, 180, 270, and then another 30, which would be negative 300. So you could actually name this point as 3 comma negative 300. If we take these degree measures, we could also utilize their radian measure. So pi over 3 would be the same as 60. So if you're ever asked to use radians, you could do that as well. So tons of different ways that we can describe this location. That's a big difference between x and y rectangular system, or the Cartesian coordinate system, and then polar here. So the next one, we've got to go negative 3 and then 240. We've got 4 pi over 3 there. And then 3 negative 300. Now what I do is I just use this graph as a cheater, so I know that this is 300, but 300 is the same as 5 pi over 2. So I'm just going to put a negative sign in front of, 5 pi over 4. Put a negative sign in front of that 5 pi over 4, and that's totally negative 300 degrees. Let's do B. We're going to go a little bit faster now. We're going to do the same thing. We're going to try and describe this location of point B, kind of using it like a normal, regular old positive r, and then a positive degree measure, and then we're going to go through these ones as well. So what we can do is we're going to name the radius first. So it's 4 here, 5 there. This is at 4.5 or 4.5 if you want to write that. And then we can look at the degree measure, and it's 150. If you want to do the radians at the same time, you could. We'll just take the radian measure, which is 150, which is 5 pi over 6. And we'll close that down. Now we've got another way to do this. We want to put a negative radius in there. So whenever we have a negative radius, it means go in the opposite direction. So what we need to do is this 150, we're going to extend that line all the way across. And this is going to be 330. Again, a nice easy trick is just to add 180 to that original one. So we've got negative 4.5 and then 330, and it looks like I didn't put that on here, but it's 11 pi over 6. There we are. Okay, we'll do a positive radius. We'll do a negative angle measure now. So if we start here, we go all the way around to 180 and 30 more, which would be negative 210 degrees. And we can just use our outside labels here of the angles to do cheat a little bit here. So 210 is 7 pi over 6. So we've got 4.5 negative 7 pi over 6. One last one here so you can see how this works, and this will be point C. Point C is at 2 for the radius, and then 315. Its radian measure is going to be at 7 pi over 4. And then we could also, I'll move this up just a little bit for you, and we could also label this with a negative radius. And so we're going to go to the 180 degrees from 315, which would be 135. So this time we just subtracted 180 just to keep ourselves in the positive area. And this would be negative 2. And then we've got 135 would be 3 pi over 4. So we'll put that down. And then we've got a positive radius here, and we're going to have a negative angle direction, so this would be negative 45. And then you could take the original angle here and just subtract 360, so you could find a coterminal angle if you think more numerically like that, that's fine. And this will be 2 then, negative pi over 4. And that's it.